Hi, I'm going to be working on some of the problems that are on the special factoring worksheet, and so I just listed up here some of the things that you need to know for this special factoring, right? There's the difference of squares, the sum of squares, difference of cubes, sum of cubes, and also perfect square trinomial. So all of these things show up on that worksheet, and so I was going to just work through a few of them and post them to make sure that you're doing okay with these. So the first one I want to look at is it's number 1 on the special cases side, the worksheet, and it says it wants us to factor 16n squared minus 9. And so if we're looking over here to try and decide what is it that we have, right? We've got two terms. We've got this binomial that we're trying to factor. So it's got to be, you know, one of these top 4, because those are the ones that have binomials in them. And then we want to look and see, are the terms perfect squares or perfect cubes? And so that's a distinction that you need to make sure that you make in your mind. Remember that perfect squares, right, or if you take a number and you square it, so 1 squared is 1, so 1 is a perfect square. 2 squared is 4, 4 is a perfect square. 3 squared is 9, 9 is a perfect square. 4 squared is 16, and so on. Okay, so these keep going and going and going. And I would say it would be best if you have them, you know, at least memorized up to 12 squared, which is 144. And then we also want to talk about perfect cubes and being able to recognize those as such. And again, this would be if you take a number like 1 and you cube it. 1 times 1 times 1 is just 1. So 1 is not only a perfect square, but it's also a perfect cube. If we take 2 and cube it, we get 8. So 8 is a perfect cube. 3 cubed, 3 times 3 times 3 is 27. And then 4 cubed, it's saying 4 times 4 times 4, which is 64. And then maybe we'll go one more. 5 cubed is 125. All right, so these are perfect cubes. This 1, 8, 27, 64, and 125. So when we see numbers like that in factoring, in our problems that we're trying to factor, it's just good to take note if we have perfect squares or perfect cubes. And so we can see on this first one here that 16 and 9 are both perfect squares. And so we're going to be using this difference of squares because it's connected by a subtract sign. And remember, if we have something squared plus something squared, that can't ever be factored. It's always prime. All right, so then we're going to rewrite this. So I want you to think about what we're doing here. We're trying to get it to look like this something squared minus something squared. So I'm going to write it that way. So I'm going to something squared minus something squared. So I'm trying to think to myself, what times what will give me 16n squared? Well, remember that 4 squared is 16, right? So I know I'm going to have 4 inside here. And then to get my n squared, I'd need to do n times n. So 4n is what's going to go in that first parenthesis there. And this is just, we're just rewriting it to help us figure this out. Okay, this isn't the answer yet, we're just rewriting it. And then looking here, we're asking ourselves, what squared gives us 9? And that would be 3. So now we call these different parts. So we're going to call this part A and this part B. And so it kind of goes along with what we are dealing with here. And then we can see that it's going to factor to be A plus B times A minus B. So that's why it's important to know what our A and our B are in this case. So I'll write that down. So I write this down. So in my first parenthesis, my A is 4n. So I'm going to have 4n plus 3, and then I'm going to have 4n minus 3 in my other parenthesis, right? Noticing that my a plus b, a minus b. And so that is your answer on that one. Okay? So that's how we factor a difference of squares. Let's look at number 3 next. So I'm not doing all of these, but we'll kind of get a few of these so I can work them out so you can make sure that you know how to do the other ones. But if we look at number 3 next, it says to factor 16 16b squared minus 40b and then plus 25. Okay, and again, you should notice that we have a 16, which is a perfect square, and a 25, which is a perfect square. But this isn't a binomial like the one above it was. That was a binomial, but this one's a trinomial. So that means we're going to have to look down here at these perfect square trinomials. Right? We've got something squared plus something squared. And so again on this, we want to rewrite those parts. So let's rewrite the first and last term here. So something squared and something squared, because this is going to help us to figure out what our a and b are in this case. So 16b squared, right? So will be 4b inside, because 4b times 4b gives me 16b squared. And then what times what gives me 25? That would be 5. All right, so again, I have my a part and my b part here. Oops, why did I do that? B. All right, and so then if we look at this, notice that it's saying instead of them being opposite of each other this time, we're going to have them, they're actually going to be the same term. And so when I'm writing it out, I'll write it out this way first so you can kind of see. So we're saying we're going to do 4b, and since this was a minus sign here, notice how that matches this minus sign on the bottom one. That means there's a minus sign in between them. All right, so 4b minus 5, and then the other parenthesis would also be 4b minus 5. And again, if I FOIL that back out to make sure that this is correct, right, 4b times 4b is 16b squared. 4b times negative 5. All right, so if I do these two, that gives me negative 20b. And if I do inside there, that also gives me another negative 20b, which makes that negative 40b in the middle. And then negative 5 times negative 5 gives me that positive 25. So I can see that this is going to be the way that that one factors out. So it's easier to use this idea here when you have really big numbers, right? I mean, you could do that AC method that we talked about where you multiply the 16 and the 25 together and then try and do like the box method or something like that, but that gets kind of crazy when these numbers are so big like that. And so just take notice, are they perfect squares? Then it's a little bit easier to write down. And so the other way that we can write this answer, and that we're going to be writing the answer, would be 4b minus 5 all squared. Right, because we have 4b minus 5 times 4b minus 5. So that would be how we'd want to have that answer written. Okay. All right, let's keep looking at some other ones here. I'll have to kind of come back up and look at some of those. But I want to look at maybe one like number 7. Right, so number 7, this one looks a little bit different because it doesn't have like a squared term in the front. So this one it says n to the 4th minus 100. Okay, and so when I'm trying to factor this, remember that when I said, okay, if I'm trying to do this, one way that I can look at it is I can think of it as, so what times what gives me n to the 4th? Well, that would be n squared times n squared. right? And then what times what gives me negative 100 that adds to be 0 because there's no middle term there. So we could think of it that way. So that would be negative 10 and positive 10. Right? And then you'd want to look to see if you could factor it any further from there. But on this one, it can't be factored any further. If it said like n squared minus 25, well then 25 would be a perfect square, and we'd be able to take that down further. But this is how we'll leave that answer, just like this. Okay, so don't overthink these type. Just think what times what is n to the 4th, what times what is negative 100 that adds to be 0 because there's no middle term there. Okay? And then you can always check it by foiling it back through. All right, the other ones that I want to look at are on the new part of the modified worksheet that I gave you. So I took off the last worksheet that was there before, and I wanted to put in some sum and differences of cubes because these are important to make sure that you know. So let's try a few of these. So on the back side, number 1 says x to the 3rd plus 125. So let me go back up here to where we have our sum and differences of cubes. You can see those on here. So since it's connected with the add sign in the middle, then we know we're going to be using this one down here. And I do want to give you a little way to help you remember how to do this, because I know that, you know, that might seem daunting to try and memorize, but you can see that a lot of it is the same. The only thing that's different on there is just a little bit of the signs are changing there, and so that's what we need to look at, okay? But again, we're going to rewrite these as something cubed plus something cubed, so we can figure out what our a and our b are. Well, here we just have x, right? X all cubed is x cubed, and then 5 cubed is 125, so I'll put 5 in here. So my a is going to be the x, and my b is going to be the 5. And so then let's go ahead and use this kind of little formula, if you will, here to use this. So in my first parenthesis, we're doing a plus b, so that would be x plus 5. And then in my second parenthesis, right, whoops, down here, is we're going to take the a term and square it, so that's going to be x squared. Then we'll take the a and b term and multiply them together, right? But then we need to change it to the opposite. So we're doing 5 times x is 5x, but then we need to make it a negative 5x. And then the last term saying take the b and square it. So 5 squared is 25. Okay. Now there's something, like I said, there's going to be a way to help you remember this, and so when you are using this difference of cubes or sum of cubes, I want you to remember to always use SOAP. Okay? Always a good thing to follow, right? Use SOAP, especially right now, right? We're going to be using SOAP. Well, what do I mean by SOAP? Well, SOAP is just a little acronym to help us remember the signs in this. So notice that our sign was a plus sign in the first one, and that stays the same in here. So this S stands for same. So our first sign is the same, right? Then the next one, our next sign there, is opposite. So we'll say, okay, so same, opposite. And then this last one, right, doesn't matter whether we're looking at a sum of cubes or a difference of cubes. Notice that those are positive no matter what. So we're going to say this is always positive. Okay? So same, opposite, always positive. All right? Use SOAP to help you remember how to do that. Okay, let's look at maybe one more on here. Maybe let's go down to do one of the bottom ones that are a little bit more challenging. Make sure you see how to do it. Let's do number 12. So number 12 says negative 27 u to the third, and then plus 125. Okay. Whenever you see a negative on your leading coefficient, it's always a good idea to factor that negative out. So that's what I'm going to do first. So if I factor that negative out, then I'm really left with 27u cubed minus 125. Right? It's like I'm dividing a negative 1 out of both of those. Okay? Negative 1 is still part of my answer. All right, but now let's look at these parts like we did before, and I'm trying to rewrite this as something all cubed minus something all cubed. All right, so here, right, with our 27, so we're trying to think of what times what times what is 27. All right, and that would be 3. And then we still need to remember that u in there also. So if we did 3u times 3u times 3u, right, do you see that we'll get 27u cubed? Right, so we're just trying to rewrite this in a way that we can figure out what this a part is going to be. Right, and then what cubed gives me 125? Well, we just dealt with that one on the last one, so that one's going to be 5. Right, so again, now I'm going to call that 3u my a part, and the 5 my b part. And still keeping in mind that we still have that negative 1 out there that still needs to be part of the answer. Okay, so let's move over here. So if I say, okay, I've got negative 1, and then in my first parenthesis, right, since this is, well, let's use SOAP to help us figure this out with the signs, all right? So it started off as a positive, but then we factored out that negative 1, so we're really looking here, right, and what's happening here. And so we have to say, okay, the first sign's going to be the same. So I'm going to have in my first parenthesis a, and then minus the b. So the 3u minus 5, right, the a minus the b. And then in the second parenthesis, I'll take my a, and I'm going to square it. Right, now think of that. I'm going to do that over here because it's saying 3u squared, which means 3u times 3u. So that's really 9u squared, right, when you simplify that out there. So make sure you write it down that way, 9u squared. All right, let me maybe go back up here and just make sure everybody's remembering, right? This is what we're doing right here. So I just did my a squared, and then I'm going to do my a times my b, and then my b squared. Okay, so my a times my b is the 5 times 3u, which is 15u. But then we've got to think again, okay, let's use SOAP. So it started off as a negative there, right? So we had the same. The opposite, so this one means it's going to have to be a plus there, right? And then the last sign is always positive. And then we'll take that b part and we're going to square it. So 5 times 5 is 25. And that whole thing right there becomes your answer. And then always double check your SOAP thing, right? You're going, okay, same, yep, opposite, always positive. And something that's kind of interesting on this is this trinomial here, when you factor a difference of cubes or a sum of cubes, this is always prime. So some students try and see, oh, could I factor that down further? And it can't ever be factored. Okay, this can't be factored any further than that. This will always be prime when you're doing that. Okay, I hope that helps. Reach out to me if you have more questions, okay? Have a good night.